Hello. Hello, hello. Can you hear me? Hello, can you hear me? Hello. Hey, hello, everybody. Hello, we'll start in 2 more minutes plus, okay? Hello. So fast ask for comfort already. I don't have, yeah, not for science today, not for physics science. Yeah. Ah, yes, Elvis. Yeah, it's for tomorrow. Hey, hello. Your Hannah, right? Hello, hello, capybara lover. Yeah, hello. Hannah is still watching. Hi, Mio. Hi, WL. We'll start soon, okay? Okay, just to let you all know, okay, those of you who are P6 this year or primary 5 to primary 6, we actually have online classes, okay? So you can try out, okay, for all the different subjects. All right, if you're Sec 1 and Sec 2, we have math as well for online classes. Hey, you met me before? Where? Hi. Yeah, Hannah. Only got math. Oh, okay. Hello, Mio. September bootcamp. P5 bootcamp, is it? Or is it P6 bootcamp? Okay, time's up. Okay, everybody. All right, so you don't know, cannot remember. Oh no. You are P6 this year? Okay, everybody. All right, I am going to start. All right, for today, right? Let me turn off this one first, okay? Okay, yeah. For today, we'll be going through energies and forces, okay, of primary 6 science. All right, so let's head to question 1. Okay, so if you know the answer, all right, you can share your answers with me through the chat. Okay, so I only can show you part of the question, not the banners on top is going to block. Okay, so let me start off with the top first. All right, it says here that John carried out an experiment using the setup below, All right, so what happened is always identify a changed and measured variable. Okay, no Kahoot today. Yes, yes, it's the PSLE. Oh, that means you are secondary one this year. No Kahoot today. Sorry about that. Okay, so all right, everybody, let me start with this first. Okay, so always remember to identify your changed and measured variable in your experiment. Okay, so for this case, all right, you can see that he measured the length of the spring where there was no weight on the pen. Okay, you must always remember to take down or take note of the important key points in your science question. All right, next, he continued to measure the length of the spring again every time he added a weight on the pen. All right, okay, so, oh no, Mio. Like that, you join again? Because it's too advanced, because the boot camp is going through like exam papers. So like if you never learned the content before that, that will be quite difficult. Okay, so everybody, all right, so can you tell me what's the changed variable? Any idea what's the changed variable in this experiment? Any idea? Does anyone know what's the changed variable? Yeah. The very good WL, that very good Lakopikia. Yeah, it's not today. Kahoot is not today. Okay. So, okay, everybody. So what happens is that, all right, wait, because look at this. What's a change variable? Change variable is something different in an experiment. Okay, so you can see from here that he added a weight. He added one. After that, he added another weight and so on. Okay, so what happens is that the weight is my change variable in this experiment. Okay, so what happens next is what's my measured variable then? Does anyone know? Measured variable, what did he record in this experiment? Anyone know what he record? Don't know? Kayla, good. Lakopi can also can. Okay, so yes, so he recorded the length of the spring, but why? Why did he record the length of the spring? He's trying to find out the extension. How how much extra did the spring extended? Okay, how much longer did the spring become? So take note. Okay, when you record the length of the spring when there's no weight, this is actually the original length of the spring. This is when there is no extension. Okay, so you all have to be very, very, very careful with this. Okay, so why we must be very careful is that, all right, he is drawing. Always read the exam question when it comes to graphs. Okay, always look at what they are recording. They are recording the relationship between extension of the spring and the weights used. So which one of the following graphs is correct? So do take note, extension is not the total length. Okay, so a lot of students will make careless mistakes here. All right, so take note that this is my measured variable in terms of extension. I want by measuring the length, I'll calculate and I'll know my extension. Okay, so take note that when I'm finding out extension, yes, very good. Okay, those of you who don't know what's extension, right? Extension, look out for the word EX, extra. Okay, extra means how much longer did the spring become. All right, so for this, okay, you will notice that, right? Whereas I put more weights, what happened to extension? What happened to the extension? Does anyone know? Yes, extension, take note. Where is my extension? This is the original length, okay, of the spring. Wait, let me try to draw a straighter line. Okay, this is the original length of the spring. All right, the extension is here, here. Okay, so what do you notice is that we notice that the more weights that are added, very good, the greater the extension, right? Whereas as the weights increase, okay, so as the weights increase in weight, all right, the extension increases as well. A lot of you, okay, so a lot of you send me 1, some send me 2, right? So this is where you make, so this is the part where I need to focus on, where I mentioned just now, students make careless mistakes, right? So over here, extension increases. Okay, but you need to understand, extension means extra, right? So where if you look at the graph here, the corner of the graph, the left side of the graph is always 0. So if there is 0 weight, should there be any extra length? Should there be any extension when you never put anything onto the pen? Okay, a lot of you say no. Very good. Those of you who say no, you are correct. There shouldn't be any extra length. It should be at its original length. Original length means no extension, which means that it is supposed to start from 0. So this one, take note, this is not correct. I cannot start from here because here means it is not 0, which is wrong. Okay? Take note, it must start from 0. So the correct answer is actually 2. Okay, 3 and 4, I'm very sure you all know is definitely wrong. All right, but a lot of students will pick between 1 and 2. Okay, so 2 is the actual answer. Why? As I mentioned earlier, okay, extension must start from 0. Because at the start, this is the original length. This is the starting point. Sorry, yeah, I keep accidentally clicking on back. Okay, this is the start. This is no extension. This is the original length. Okay? So, all right, so you must understand this part. It must start from 0, nothing extra at the start of the experiment. Okay? So your answer for this is supposed to be number 2. Okay? Okay? Okay, I'm going to move on. Everyone okay? Yeah, it's 2. Yes. Some of you initially put 1, right? So y'all don't get tricked, okay? In PSLE or in your school exams, please be very, very careful at the starting point of your graphs. Okay? Okay, so let's move on. Okay. Yeah, that's good if you put 2. Those of you who didn't, at least you all know now what to look out for. Okay, if they put extension, it must start from 0. If it's, okay, let me repeat that. If this put length, then it's different. Okay, length, if this one is length, then option 1 will be correct. Understand? Okay, but if because it's extension, I cannot choose option 1. All right, I'm gonna move on. Okay. Yeah. Okay, everyone, all right? I'm gonna go to number 2. Okay, number 2, all right, it says here that don't drop a ball on the ground as shown. So the question is asking, which one of the following graphs correctly shows the energy conversion that occurred from A to B? Always look out from the starting point to the ending point. Hello, Crystal. You rush for the TikTok lesson after your dinner, so you ate already? Oh, I haven't eaten. I'm very hungry. I'll eat after that. Hi. Hi, Vicky. Hi, Yansen. Okay, so you all must understand the key over here. At what is the position of this? Always look at the graph first. They are focusing on what? They are focusing on energy. So if you focus on energy and they are focusing on potential or kinetic energy, okay? Oh yeah, I will eat after that. Okay. Oh, thank you for the likes, everybody. So cute of you, Bernard. Okay, so over here, what happens is that you must know at what are the variables affecting this energy. So let's talk about potential first. Okay, so you must understand at A, can anyone tell me at A, potential energy is the highest or is the lowest? Does anyone know? Okay, good. It is the highest. Very good. Because why? Potential energy depends on the height. The height above the ground, what height the object is, affects the amount of gravitational potential energy. To be more specific, is gravitational potential energy. Okay, so let's write this one down. So you know that at A, okay, GPE, gravitational potential energy, is the highest. Okay, but what about kinetic energy? Yes, height and mass, right? But this one, same ball. Good. Height, very good, JL. Height and mass are the factors that affect gravitational potential energy. But in this case, the mass is the same. So we focus on height. Lowest, or let's be more specific. Is it lowest or exactly zero? You know? Okay, kinetic energy. Kinetic energy. Okay, over here, right? It is actually zero because the person is still holding on to the ball. The ball is not moving yet. Okay, so for this, kinetic energy, okay, is, to be more specific, is actually zero because there is no movement yet. Okay. Very good. Okay, so now what happens to gravitational potential energy when it reaches B? It hits the floor. It's directly touching the floor. Very good. A lot of you put zero, right? Okay, good. So yes, gravitational, but now it is touching the floor. It is not at a height any longer. So gravitational potential energy is actually at zero over here because it's on the ground. Okay. What about kinetic energy then? Kinetic energy is usually the opposite. Let me give you a clue, okay? Kinetic energy is usually the opposite of gravitational potential energy. So kinetic energy will be the highest. Very good. Okay, so kinetic energy is the highest. Okay, so based on this, very good, a lot of you, Kayla, Amoy. Let's go, yes. So based on this, you can see, let's talk about potential energy first. Potential energy from high to zero is increasing or decreasing? Highest to zero, increase or decrease if it's high to zero? Potential energy is decreasing. Very good. So potential energy is supposed to decrease. Very good, everybody. And what about kinetic energy? You see, kinetic energy at first is zero, then one, then suddenly become the highest. It's supposed to be for kinetic. Very good. Kinetic is supposed to increase. Good. From A to B. So based on this, which graph would you all choose? Let me scroll down a bit. Which graph do you choose? I'll wait for a while for your answer. Oh, very good. I've seen some answers. Good. Yes, the correct answer is 4. Okay, so very good. All right, so the answer is 4. Okay, most of you got it correct. Very good. Okay, everyone clear so far for this? Yay, okay, very good, all of you. All right, so let's move on to the next one. Okay, let me move on. Okay, so this one is actually very straightforward. Very, very straightforward question. A boy, okay, I'm gonna highlight the keywords. Put a box up a slope, all right? And which of the following correctly shows the direction of the forces acting on the box? So gravitational force, you all should know gravitational force. Oh, a lot of you sending your answer already. I've seen 1, I've seen 2. I've seen 1, I've seen 2. Okay, so the correct answer is actually 2. Okay, yes. Okay, a lot of you got it correct. So why 2? Okay, so 2, always remember gravitational force is always a downwards pulling force. Okay, so gravitational force should be B, downwards. Okay, not never C. All right, so 3 and 4 is already out. Okay, so what about frictional force? Okay, frictional force, always remember, opposes motion. Okay, oh no, always remember gravitational force is the pulling force downwards, not to the side. Gravitational force will never pull things diagonally. Okay, so everybody, so take note, okay, so frictional force, all right, is a force that opposes motion. Okay, opposes motion basically means that it goes against your direction of motion. So which direction is the boy here moving? The boy is pulling the box up a slope. So up, this C is actually the boy's movement. The box and the boy is going in the same direction as C. Okay, C is actually its motion. Okay, and frictional force opposes motion. It goes in the opposite direction. So frictional force will be A. Okay, so based on this, your answer is supposed to be number 2. No. You mean what? Gravity? Gravity always is down, directly down, not diagonally. It will never be diagonally. Okay? Okay, so let's move on. Thank you for all your likes. But you all concentrate also, okay? Don't just be busy liking. Okay, so everyone, all right? Oh, am I speaking very fast? No, you all can understand, right? Okay. I cannot be speaking too slowly, okay? Okay, everyone, you know, cannot finish. All right, so everyone, let's move on, all right? So let's move on to 4. Okay, so let's look at this one over here. All right, let's highlight the key things. Oh, if you know all this stuff, you will think that I'm slow. Definitely because I need to explain. If you know all this stuff already and you are very strong with your science, then yeah, then you might think I'm going a bit slow. Too bad I need to explain, okay? Okay, so let's look at 4. Okay, Amy conducted an experiment where she dropped a steel ball onto a tray of damp sand. Okay, so over here, what happened is she dropped a steel ball. All right. Oh, okay, no problem, Kayla. So that's why you're here to practice, right? Yeah, of course you cannot see the options. I need to go through the top part first. If not, how? Okay, let me go through the top part first. Okay, be patient. Okay. Okay, so over here, she dropped the steel ball onto a tray of damp sand. Okay, and what happened is she measured the depth of the dent made by the steel ball. All right. So what happened is she repeated the experiment by dropping the steel ball from different heights. Okay, and she recorded the depth of the dent made by the steel ball in the table below. Okay, always remember, in an experiment, identify your changed and measured variable. Damp means wet. Damp means wet. Damp basically means the sand is wet. Okay? Oh no, it's some of it is school papers, school questions. Those popular ones will pick up. Yeah, is your school also actually take questions from other school papers and use it actually? Okay, so everybody, what's my change variable here? No Kahoot today. Yeah, if you need to go toilet, just go ahead. It's okay. This is TikTok live. Don't need my permission to go toilet. You want to go toilet, can go ahead. Okay, I seen height. Very good. All right. Oh no, not weight of the ball. Change variable, not weight of the ball. He dropped a steel ball, the same ball. Okay, so the change variable is something that is different. Okay, so different heights. You see, look out for the word different heights. This is my changed variable. Okay, so what is my measured variable then, everybody? Why you say skibidi? Hello. Yes, it's the depth of the sand. That means, okay, that means, right, how deep did it goes into, like this. Okay, so either it goes very deep or just a shallow depth. All right, so basically depth means how deep did it go into the sand. All right, so this is my measured variable. Okay, does anyone knows why must I measure the depth? What does it tells me? It will tells me the what? Does anyone know? Hey, don't use Reese. Does anyone know? Don't know? It will tell me, they will actually tell me, okay, how much force, how much energy an object have. Remember? Okay, because different height means there'll be different gravitational potential energy, right? Gravitational potential energy is my change variable. So if I release it at different height, it will have different amount of kinetic energy. So they'll give me a different amount of force. So the depth of the cell will actually tell me how much kinetic energy or how much force an object has. Okay, very good, very good. Okay, so what is the relationship? Everybody, when it comes to relationship, let me go to the question now, okay? So you all can see the options. Okay, so what is the relationship between height at which the steel ball was dropped from and the depth of the dent? Okay, so always remember for relationship question, what must you all use? You always use words like increase or decrease. Gravitational potential energy. What is gravitational potential energy? Gravitational potential energy is a stored energy that an object has when it's at a height above the ground. That stored energy, that's what allows it to drop because it has some stored energy inside of it. Okay, so one or two, what do you all think? Four or two, what do you all think? Four or two? Okay, everybody, you all must know. Yes, okay. Everybody, you must know, okay? Do not choose. Okay, anyway, do not choose one or two in the first place. You know why? Okay, you always remember, okay? When it comes to relationship, you must think what affects what. Always remember, you only change the change variable. You change the height of the steel ball, then it will affect my results. It will affect how deep the stand the dent is. Okay, so always remember for relationship question, okay, write down your notes for this one if you have. Okay, very important. Okay, relationship question, always remember that the change variable affects measured variable. Okay, so you must talk about the change variable first. We cannot, since depth is my measured variable, cannot talk about the depth first. I will cross out 1 and 2. Okay, understand? Everybody okay? So change variable, the ball, the height of the ball will affect my results. Change variable, change first, then you affect my measured variable. So what happened is the answer is number 4. Okay, when the height the steel ball was dropped from increases, the depth increases. Okay, very good. Yes, very good, Kayla. Yes, I just saw all your chats. Very good. Okay, you are supposed to mention your change variable first. Okay, very good. Everybody okay so far? Any questions? The answer is 4. Okay, I screw up a bit. Why got money? So funny. No time for what? What happened? WL, what happened? No time. Hi. Okay, everybody, I'm gonna move on, okay? So let's move on to your favorite open-ended questions. Oh, it's okay. You're still eating dinner. No, it's fine. You can watch the recordings later. If you have the paper, if you print it out, you can do it later. No problem. Got recordings on. Okay, the recordings will be released later. Problem. Okay, everybody. Oh no. Okay, let's look at question 5. All right, study the toy shown below. Okay, they mentioned that Carol twisted the rubber band in the toy by turning the top of the wings of the toy 10 times. Okay, so next they said that when she released the toy, it stayed in the air for a while. Okay, I'm very sure you all know why it stayed in the air because it's moving. Okay, before dropping to the ground. So fill in the boxes to show the energy changes to the in the wound up toy when it was when released. Okay, so they always remember when it comes to energy conversion. Oh, they usually release in the website. Our website, the our website, the TikTok live website, A grader website. Then you navigate, you will be able to find the one that's something to do with TikTok. And then the recordings are actually released at all the way at the bottom. Okay? Yeah, you can click on, yeah, YouTube also have, but if you want to know, you want to go to the specific one, you go to our website. Then you know like which day, which lesson you miss, then we'll link you there. Okay? Hey, very good. Sakina, very good. Foxy, yes, very good. Okay, if you know your answers, you all can send to me, okay? All right. Okay, so very good. So over here, always remember, there are clues in the question. They already say the twisted rubber band. When a rubber band is twisted, okay, very good. A lot of you got it correct. Okay, it means that the rubber band has been stretched. Okay, and a stretched rubber band will possess elastic potential energy. Okay, just take note, okay? In stigma, stigma is the female part of the flower, right? Okay, anyway, all right, so take note in PSLE, the word elastic actually not required, as long as you mention potential energy is good enough. But I know some of your school teachers will expect you to write down the specific potential energy. So follow your school teacher, okay? If you write the correct potential energy, you won't get penalized. All right, so elastic potential, hmm? They will not give you such a huge clue. They will just say rubber band. They will not tell you that it's elastic band, because elastic band is like giving away the answers already. Okay, so then the moment you see when it release, right? When the toy is released, the toy will move, correct? So any movement will be kinetic energy. So elastic potential energy will be converted to kinetic energy. Okay, very good. Eddie, potential energy is stored energy. Force is similar to kinetic energy. So, okay, so for example, when I'm pressing the rubber band, when I'm stretching the rubber band, when I stretch a rubber band, right? I haven't released it yet, I haven't let it go yet. Okay, I stretch it. It has elastic potential energy, but it doesn't exert a force yet. Okay, until I release it. Okay, okay. A force is more similar to like kinetic energy. It exerts a force onto an object. Okay, can? Okay, usually a force is when it exerts a force, an object will move, right? So it's more related to kinetic. Okay, so it's slightly different. All right, so forces and energy, please don't confuse them. They are slightly different. Okay, so everybody, all right, energy is just thought, no movement yet. Elastic potential energy, no movement. Okay, all right, so everybody, let's move on. Okay, to B. All right, so B. Everyone okay? Yeah, converting is 3 marks. This kind of part A is actually like 3 marks. It's the easiest to score. Okay. All right. So without changing any part of the toy, okay, we need to suggest a way to make the toy stay in the air longer. So if I want to stay in the air longer, means it must have more or lesser energy. What do you mean? School say they're testing energy first. Then you just focus on energy. Don't need to think about when are you going to learn about solar. Solar energy basically is light energy. So don't use solar. Don't use the word solar in PSLE. It's not tested. Okay, just use light. Okay, so all right. So everybody, if I want, yes, very good. All of your answers are correct. Spiritual energy. Hello. We are not doing religious. This is science. Okay. So everybody, all right. Stay in the air longer means that you need more elastic potential energy. Okay, so if I want more elastic potential energy, I can actually twist the rubber band more times. Very good. How do I stretch? Okay, you got the idea there, Mio. Stretching the rubber band longer. But in this case, how do I stretch it longer? I twist it. Okay? So, suggest a way I can twist the rubber band more times. Okay? Make the wingspan bigger. Yeah, that is correct, Elizabeth. Provided they allow you to change the toy. Okay, but now they say, right, without changing any part of the toy. Okay? Okay, Elizabeth, yours is not wrong. If they allow you to change the toy. Okay, can? Yeah, okay. So everyone, all right? So I can twist the rubber band more times. Okay, so I'm gonna move on to C. Let it go at a higher height. But she's let it go at a higher height. It just what happened is that okay, that's not wrong, but I want it to stay in the air longer. So we usually change it. We usually change the bend. We usually twist it more. That is not wrong also. Let it go. Let it go at a higher height. Okay, but let it go at a higher height, right? Yeah. Use a fan. You all start adding other things already. Okay, we try to do what we have with the toy. Don't add anymore. Don't add things in the experiment. Okay. Okay, everybody. I'm gonna move on to C. Yeah, technically correct for the higher height. Okay, can? All right, so everyone all right? So we need to explain our answer. So what are we going to do? So explanation question, when it comes to energy conversion, you must be very, and yes, science you must explain. They want to know how come you know must twist the rubber band more times. All right, so over here, all right, you need to, when you explain, in 8th grader, we teach either 2 or 3 steps explanation question. Okay, so for this question, all right, when they never tell us, they never give us the result of the experiment, right? So it's without results. So we use the 2-step answering technique, describe and science concept. CER. Oh, you can use CER, but for 8th grader, we use either DSL, describe, science concept, or link. It's the same. DSL, CER is the same. Okay, but for us, for this one, we use 2 or 3 steps, DS or DSL. Okay, so for this is not an experiment in a way whereby they never give us the result. They never give us the result, right? So we use 2 steps. Okay, so we use 2 steps. Your different school got different ways, okay, of like teaching you how to answer open-ended questions. Okay, so for this, D means describe. First step, describe. What we need to describe? You mentioned this, right? Twist the rubber band more times. So we need to describe. When you twist the rubber band more times, how does it help? Okay, so you talk about the rubber band. You must say when there are more turns on the rubber band, there will be more what type of energy? More type of what kind of energy? Does anyone know? Yes, there'll be more. The rubber band will possess more elastic potential energy. Very good. Then you already done your describe. You done your first step, describe. Okay, second step, science concept. Talk about conversion. Then how does it lead to the toy being in the air for a longer period of time? So you must talk about energy conversion for your second step, science concept. S means science concept, okay? All right. So you need to say that this more elastic potential energy will be converted to more what? More, you get more when you twist it more times, you get more elastic potential energy. More elastic potential energy can be converted to more. Okay, must use comparison words, okay? More kinetic energy. Very good. Which allows the toy to stay longer in the air. All right. So that's how you answer. 2 steps. Okay. Answering technique. So let me write down, okay? Oh, happy birthday, Kayla. Oh, lucky they didn't study. All right. Okay. So with more turns of the rubber band, I'll write the D in red, okay? The first step, describe. Describe will give you 1 mark. Science concept will give you another mark. All right. The rubber band will possess. This possess is not the spiritual kind of possession, okay? this is just energy, okay? Someone was talking about some other things just now. More elastic potential energy. All right. To be converted You notice that I changed to blue already, okay? This is my science concept. To more kinetic energy of the rubber band, which is converted to more kinetic energy of the toy. Okay, why do I talk about the rubber band first? It's because the rubber band need to move to push the toy. Some school teachers, okay, wants your expects you all to write step by step to show exactly from which object to which object in terms of energy conversion. All right, so to be very careful to prevent any loss of marks, okay, please write the object down as well. Okay, kinetic energy, more kinetic energy of the toy, plus the toy can stay in the air longer. Oh yeah. Hey, don't. Yeah, stranger danger. Okay, make sure your profile don't have any of your photos. Okay, if you're gonna tell other people your school, that's a bit risky. Okay, all right, everybody, I'm gonna highlight the key things. Okay, I'm gonna highlight the key things that you all must write down your answer to obtain your full marks. All right, you all must mention more turns. There'll be more elastic potential energy, converted, more kinetic energy, converted to more kinetic energy of the toy. Okay, so it can stay longer in the air. Wow, what you're right. You're right so much. You're type so much in the chat when I'm busy writing. Or WL, science is like that. Yeah, because you need to explain. If you don't need to explain, then don't need to write so long for the 2 marks. But if they need to explain, then yeah, they want to make sure that you understand the science. You understand the concept. That's why you have to write longer. You love typing. Okay. Everyone okay? All right, I'm going to move on, all right? Yes, I hope you all do well for your PSLE. Okay, so everyone, all right, I'm going to move on. Okay, so now, capybara lover, that's a bit strange. Okay, so let's move on, okay? All right, so let's look at 6. All right, for question 6, it says that the diagram below shows the path of the ball after this person kicked it. All right, so if you all know the answer, you all can tell me. Okay, the ball moved from S to T to U. So, besides the force exerted by Mingli on the ball, state another force that is acting on the moving ball. Ah, I give you a clue, okay? This force acts on everything all the time. Hey, the easiest. This force acts on everything all the time. Friction is okay. If you're gonna talk about friction, you have to be specific in this question. But since okay, because I understand that you must be thinking about air resistance. Air resistance, yes, is a type of frictional force, but you because they call you to talk about force here, try to mention something that is force. If not, you have to be specific and write air resistance. Okay? Yes. Hey, yes, I miss Jody. Yes. The leader. Okay. Yes, a lot of you got it correct. Gravitational force is the better answer. Okay, because they want you to be specific about the force. Okay, so yes, gravitational force is acting on the moving ball all the time. If you write air resistance, you will not get it wrong also. Frictional must be for air resistance and water resistance, you must be more specific. Okay? Can? But if you write frictional force, your sum depending on how strict your school teacher is actually. Okay, Ken? All right, so everybody, I'm gonna move on. Okay, so let's look at the next one. Okay, it says that next, this person kicked a heavier ball from the same starting point as, okay, with the same force. Okay, highlight the key things, okay, same force and the same direction. In the diagram above, draw the path of movement of the heavier ball. Oh, thank you for all the likes. Okay, everybody, listen carefully, okay? When it comes to this type of question, a lot of students have made this mistake. Y'all don't see any line, y'all skip the whole question entirely. I've seen a lot of students do that, okay? So everybody during exam, please look at the question carefully, question part. No lines doesn't mean don't need to do anything, okay? You need to do something, all right? Need to draw the path of movement of the heavier ball. Okay, can anyone tell me if the ball is heavier? Okay, let me draw for you. Should the ball move like this? Okay, the orange color line, or it should be the red color line. If it's the heavier ball. What do y'all think? Orange color line or heavier ball got more energy? Orange color line or red color line? Okay, very good. A lot of you got it correct. It's supposed to be red, not orange. Okay, let me erase off the orange. It's not supposed to be the orange line. Okay, why? Why is because, okay, when the ball is heavier, mass affects what kind of force? Mass affects what kind of gravity? Very good. So everybody, okay, so please remember, okay, when you use a heavier ball, there will be a greater gravitational force acting on the ball. So there'll be greater force pulling the ball down. So when there's a greater force pulling the ball down, okay, the ball, the path will be at a lower height as compared to the initial height. Okay? Very good, a lot of you. Very good. More gravitational force. Very good. Okay? So I'm going to move on. Okay, to the next one. Next one. After Ming Li kicked both balls, okay, he noticed that the ball will bounce a few times and roll a short distance on the ground before coming to a stop. Hello. Let's talk about science, okay? Okay, everybody. Okay, so yes, thank you, Bernard. WL, let's focus on science. All right, so describe the force that has caused the moving ball to stop rolling on the ground. Describe, everybody. They did not ask you to just state. They call you to describe. So please be very, very, very careful. Okay? Focus, everybody. So what is the force that causes it to stop rolling? Stop. Very good. I've seen some of you. YS, thank you. Force. Everybody, this is force. Force, not energy anymore. Force, okay? Force. Hello. This is force. Why I still hear? Why I still see people telling me kinetic? Force. There's no such thing as kinetic force. Oh no, it's force. Oh, no such thing as kinetic force. Oh, you haven't learned force? Some school already started on forces already. Okay, I give you a clue. The thing that stops, everybody, the thing that stops the ball from moving is supposed to be an opposing force. What force opposes motion? Just now I just went through. Not past motion, okay? Opposes motion. Yes, friction. Very good. A lot of you got it correct. Okay, but they call you to describe. So you cannot just say friction, the end. What exactly? Frictional force between what and what? Always remember, when they call you to describe, you must say frictional force between what and what, everybody? A lot of you very good. Fauzi, Shakina, Bernard, very good. Friction. Yes, Kayla. Frictional force between the ball and the ground. Very good. Okay, so good. So you have to write down frictional force between the ball and the ground opposes the ball's motion. Okay? The next page is the last page already. Okay, everybody? Next page. Hey, ends at 8, you know. If this page is the last page, then how? Okay. All right. So, frictional force between the ball and the ground opposes motion. Okay. So, when read the question carefully, those of the students who just write frictional force, you get 0 because you didn't describe. So, during exams, during PSLE, please read the question very carefully. Okay. You can eat ice cream. What ice cream? I want to eat also. Oh, thank you, Kayla. So sweet of you. Everyone okay? Yes, a lot of you got it correct, okay, for the above. Very good. A lot, is it? How many of you already learned forces in school? Heaven or Elizabeth Heaven? Oh, Foxy learned already. Very good. Oh, Ellie, very good. Swing mascot. Okay. Oh, you just started. Okay, don't worry. Just started learning energy, Rainy? That's a bit late, you know. Oh no. Okay, don't worry. At least now you at least got some idea about what frictional force is, what gravitational force is. So when your school teach, you should be clearer about that. Okay, so everybody, let's look at the next one. Okay, so they say here, all right, that gravitational force acts on all objects on Earth. Okay, you haven't learned no Kahoot. This lesson no Kahoot. Tomorrow have Kahoot. Oh, Fauzi, yeah, you learn early. It's good. It's good that you learn early. So you go school, you are sure about all the things that your teacher is teaching. Okay, so over here, gravitational force acts on all objects on Earth, all right, so that they do not fall into space. Okay, so gravitational pull on Earth on ball A has been drawn for us in the diagram below. Now, in the diagram above, draw an arrow to show the gravitational pull of Earth on ball B. Okay, so let me give you 4 different options. Okay, 4 different options. Okay, so those of you who don't know, this is Earth. All right, this is Earth. Ball A has been drawn. Okay, always remember it's a pulling force on that Earth exerts, so it can pull objects towards itself. Okay, so I give you 4 options. All right. Option number 1. Option number 2, black color line. Blue color line. Oh, sorry, blue color arrow or purple color arrow. Which one do you think it is? Which color is correct? 2, yes, 2 is black. Very good. Which color is correct? Very good. A lot of you got it correct. Yes, it is the black arrow. Very good. So, gravitational force will pull ball B towards, Earth will pull ball B towards it. Earth will exert a gravitational force on ball B and pull it towards it. Okay, very good. A lot of you. Hello, these are colors. You all learn colors in nursery. Cannot be all of you are racist in nurseries. So funny, you. We are describing the color of the arrow, not describing color of people, okay? So let's move on to the next one. Okay. Yeah. Okay, so let's move on to the next one. Ming Li had a battery-operated toy train. All right. So he observed that the toy train moved slower from X to Y than from Y to Z. This is notability. Okay, those of you who want to like write things on your iPad, you can actually use notes. You know, iPad got files, right? There's a file. Actually, when you open the file option, you can click on the pen button already. Yeah, as long as you have Apple. I'm not sure about Android, but you can do that on iPad. Okay, everybody, I'm going to move on, okay? So, over here, explain in terms of force, why explain, okay? Explain, everybody. sometimes certain school, right, want to torture you all. Okay, so no choice. Even if it's an explanation question, they give you only 1 mark. Okay, even if an explanation question, they only give you 1 mark. All right, so explain in terms of force why the train moves slower, okay, from X to Y. So everybody, Y to Z, you actually move faster. You notice, right, when you go down a slope, you go down a slope faster than you go up a slope. Does anyone know? Gravitational force was acting on the train, and the train was moving. Okay, we don't say acting against. We say the train is moving against. Very good. You got the idea there, Sakina. Yeah, I do teach P6. I teach the online class on Thursdays. That's the question number. This is part, no? This is part D. A, B, C, D. D part 1 and D part 2. Okay, very good. A lot of you got it correct. Very good. So everybody, what happens at X to Y, right, is at, okay, so everybody, X to Y, the, yes, the train is moving up, right? So when you're moving up, you are going against two type of forces. You are actually going against, does anyone know what forces are you going against? This one, you're going, when you're moving up, you are going against two forces. You are going against, yeah, this is the last page. Frictional force, very good. First thing, you are going against friction. No matter what, as long as the train is moving, you're always going against friction. What's the other thing? Very good, Kayla. You are going against gravity as well, because when you're moving up, gravity is desperately trying to pull you down. Okay, so that is the difference. When when the train is going down from Y to Z, okay, it is only going against friction. So you must compare. Okay, you must compare. You must say that, okay, there's no such thing as plastic energy. What's plastic energy? Okay, so you must say that, explain, describe the forces that's involved in this question, and talk about going against. What kind, and focus on which forces is it going against. All right, so what kind of forces is the train going against? So you have to say that. Okay, let me write down the answer. Okay, the train needs to go against both gravitational force and frictional force from X to Y. Okay, but you have to compare, all right? Please compare, because they use the word slower. You have to answer by comparing. Okay, so but only need to overcome or to go against frictional force from Y to Z. Okay, let me ask you a question, everybody. Those of you who learn forces, does your school teacher allow you to use overcome? Because I know some school teacher don't allow some students to use the word overcome. Or some allow, is it? Some yes, some no. Oh yeah, I heard about mixed answers as well. I heard some say yes, some say no, some allow. Yeah. Okay. That's why I put go against here. Okay. So I know some don't allow, but go against all your school teacher allow, right? Go against this. Can I repeat again? No, I'm just asking. Yeah, WL, you're talking to me, is it? I'm just asking whether your school teacher allows you to use the word overcome, like overcome frictional force, overcome gravitational force. Well, some of you say yes, is it? Yeah. Okay, so teacher say better not to. Some say yes, right? Some say no entirely. Okay, so don't worry, don't worry. That's why I use go against here. Okay, so but you all accept go against, right? Most of you. Okay, so for this, all right, the train need to go against both gravitational force and frictional force from X to Y, but only needs to go against frictional force from Y to Z. Yeah, so you go against. Oh, capybara, try to focus, okay? Don't say weird things already, okay? Yes, this is P6. What happened? How come someone you all just join but I'm ending soon already. Okay? Okay, everybody, any questions so far? Lakopikia, that sounded very strange also. Any questions? Okay, so no questions. Okay, so I just let you all know, okay, we do have online classes for P5 and P6. Okay, you all can try it out. Okay, I'm teaching the P6 online class. Okay, so you all can try it out a free trial by going to our website. Okay, and also, all right, there will be another live tomorrow. Okay, yeah, tomorrow at 7 p.m. All right, that live will have Kahoot. Okay, can? Oh, not me. Next live is not me. I only teach P6 science. I only teach on Tuesdays. Okay, then if not, y'all can go off. Okay, thank you for coming to the live. Okay. Sorry, if y'all can any questions, I will stay here for a while. Hey, bye bye. Bye bye. Oh, I saw someone ask a question. Teacher Jolene? No. Yeah. Solar energy is basically light energy, but don't use the term solar energy. Okay, it's actually light, but we don't use the term solar energy when we are writing answers. Okay, use the word light energy because solar energy is not the term that we use in PSLE. Okay, can? But solar energy got a bit of heat energy actually also. So it's a bit more confusing, more complex, but it's mainly light energy. So in PSLE, just use light energy, okay? Oh, I'm teacher Jody. Next science live for P6. P6 is 2 weeks later on the 25th of February. Next week? No, not next week. P6. We usually alternate weeks. Yeah, next. Yeah. Hey, bye bye. Hey, I saw someone ask a question. What do you mean by salt water float? It depends on what you are putting salt water with. The less dense one will float. Like oil, if you put oil and mix it with water, oil is less dense, so it will actually float on water. So salt water, what do you mean by salt water float? So float on what? We will learn in secondary school. You will learn the density. Solar energy, they will mention a bit. Yes. But they won't focus too much on solar energy actually even in secondary school. But you will learn about density in secondary school. Coins, I have no idea how to get coins also. I don't use much TikTok. Bye bye, bye bye, Belinda. Are you so nice of you, Reese? How do you get coins? Oh yeah, see you on Saturday, Belinda. But don't waste your coin. You are so sweet y'all. Yeah. Don't. How come y'all got how to give coins? How y'all get coins? I also no idea. The one on the one who asked about saltwater float, you must tell me you want to make saltwater or mix saltwater with what? If you're trying to say that if I put things on salt water and put things on normal water, the object tends to float better in salt water because salt water is denser than fresh water. But the one not primary school science, the one secondary school. Okay, bye bye, bye bye. Pull is a type of force. Pushing is also a type of force. Force is either a push or a pull. Yeah. Reese, why you want to give me coin? I mean, but okay, but don't waste your money. If you need real money to do it, don't do that, okay? Hello, please don't talk about that thing over here. Okay, I'm gonna end, okay? If y'all know, yeah, if y'all have no more questions, I will, I will go off. Okay, enjoy. Oh, why no? So funny you. Okay, I'll go off. See you. Thank you for joining. Why? How to give coins? I also don't know, Reese. You spend money for coins? Then don't give. Don't spend your real money. Okay. What? Wait. What happened? So cute, you, Lavis. How do you get for free? Wow, you must teach me. Okay. Okay, I'm gonna go off. See you. Thank you for joining. Bye bye. Bye.